This video is on 1.7 homework, and I'm just going to touch on a few things that I've had questions about, but also some specific problems that I'll do in full. So for part 1 on inverse functions, the question asks, let p of x equals 7x plus 4 over x plus 6, and q of x equals 6x minus 4 over 7 minus x. So then you're asked to find p of q of x. So I will go through that process, doing that composition. Then you're going to do vice versa. I'll leave that one alone there. It should come out to be the same answer. And then you're going to be questioned, are p and q inverses? Based on what you found here, what is your conclusion? So first thing I'm going to go through is plugging the q of x in here, and note that my domain for this, that's one thing to always note when I just want to start, that I have to have a defined situation to start with. So it can be all real numbers, x not equal to 7 would work there, because or anything but 7 will work in this. Then once I come out with my answer, I'm also going to consider the domain of that, but the intersection of the two is what has to hold. So here for p of q of x, that's going to be the same as p of 6x minus 4 over 7 minus x. And then I'm going to plug this q function in everywhere I see x. So 7 times 6x minus 4 over 7 minus x. And then I just have my plus 4. All divided by x, which is now 6x minus 4 over 7 minus x. Plus 6. Now I need to clear the denominator. So I've done my composing, but I'm not done yet because I can't have fractions within fractions. I must simplify this. So I am going to multiply every term in the numerator and every term in the denominator by 7 minus x. What I'm really doing is, again, I have my common denominator is 7 minus x over 7 minus x, right? So I can do that because it's like multiplying by 1, and then I'm going to distribute to every term. Okay, so just so that's clear, I write that as, just kind of squeeze it in here, 7 minus x, 7 minus x there, 7 minus x there. So this is my distributing work. And then I can reduce, and I would be left with the 7 here times 6x minus 4 plus 4 times quantity 7 minus x. So don't forget to distribute. So that's going to become a 28 minus 4x. I actually can just go ahead and distribute this 7 here while I'm at it. I might as well do that here as well. So I would have 42x minus 28. Now see, if I've distributed right, I should have some things that cancel out. Then on the denominator, I just have 6x minus 4, I have no multiplier there, and then plus this 6 times quantity 7 minus x, so I'm going to go ahead and multiply that. It'll be 42 minus 6x. Then I can go ahead and literally cancel some things out, combine like terms, so the 28s will go to 0, and down here I have a 6x minus 6x. So then I'm only left with 42 minus 4x would be 38x over 38 in the denominator. So that works out quite nicely. And it just leaves me with X. So I get the identity. But be careful here, my domain is set by that inner function. So I have to be careful of that, right? So I can't have X equal to -7 or to 7. Or else I would start with a 0 in there. So keep that in mind. So the same thing here, then you're going to be looking at the inner function would be the p function there. And are they inverses? Yes, because when I compose them, I get the identity. Another thing I want to quick look at is these graphs. So if I look at finding the domain and range of f, and then I sketch f inverse and find the domain and range of f inverse, what should happen is when I look at my function f here, I'm looking at number 4. I start off at my x value. This scale is a little off kilter, but my x value here is -1. So I'm going to, these go just on the axis. So that's -1. So this is f. Domain would be -1 up to, look here, 7, 8, 9, 10. Okay, and that's not included because it's an open circle there. Okay, so that's my main function. Then I'm going to look at the range, which is the y span. So now I'm looking, if I kind of draw, let's just draw a little. This is my range here, my up, down, vertical. So I'm starting off at 1, 2, 3. So my lowest thing is -3. And it's included, and it goes all the way up to +9, but that's an open circle, so it's not included. So for my inverse, without even plotting it, I should know that, it's kind of nice, I know that it's going to flip-flop. So for f inverse, my domain will be -3, 9, and my range will be -1, 10, because the whole thing with inverses is if AB is on F, then BA is on F inverse. So that means my X and Y's switch. Okay. So to plot this, I can just look at a few key points here. So if I know, or to plot the inverse, so I have, this would be -1, -3. So if I have, I'll write it up here, -1, -3, that's a point on F. So then I know on F inverse, I'm going to have -3, -1. They just switch. So then we can look over here, 1, 2, 3, and -1. You can also think of it as they're going to reflect upon the line of symmetry, y equals x. So y equals x is just if x is 1, y is 1. If x is 2, y is 2. X is 3, y is 3. See how that goes on the diagonal. So you can do the mirror image, or you can pick some point. So if you don't like thinking, oh, that's equidistance, I can just plot a point there. If you get a little confused on how it is, especially with these twisty-turny ones, you can actually just pick a point. So however that works for you, however you like to do it. Sometimes I like to, switch it up. But for this one here, for instance, if I have 7. So on my regular graph, my original function, I have 7, 8. Then that means 8, 7 is on my inverse. Should be a little hard to see here. So I have 8 and then 7. So I think my little line of symmetry is a little crooked. Okay. And then you can just go ahead and get the general shape along the fold. Doesn't have to be perfect. Okay. If you get a few key points in there and mark it down, and then just know that the domain of the original becomes the range of the inverse. And remember, we do have to have it be a function in order to talk about inverses. So now we're going to look at finding these characteristics of each of the functions below. So find domain and range, find inverse, find the domain and range of inverse, and then state, do the composition and state the domain, and sketch on the same set of axes. So I think I gave you, I'm not sure if I gave you all the graphs. I will give you the graphs. I do have those probably on a separate sheet. So you can just put it into a graphing calculator if you want, because these are part of a, they are actual functions. We're not doing like where transformations and we had transformations being performed and saw stuff happening to the input and the output. These are a different notation here. Notice these are just functions off to the right. I just noticed the numbering's a little off here. So this is really 6, 7, 8, 9, and 10. So I think I had some questions on number 10. Or aka 14, probably wasn't 6 because that's pretty straightforward. So I'm going to do number 10 here. And I can do any others if you just ask questions about them. So for number 10, we are going to, I like to just replace the f of x with y just because it makes it a little cleaner at first for me. I'm going to do it up here just because I have space. Hopefully you did yours out on separate paper for me. So then the y would become x. And then I have negative 1 over 2y. So my x becomes a y minus 4 in the denominator. So plus 3 is tacked on to the right. So what I want to do is isolate my variable here of y. So I'm going to solve all around. So I'm going to subtract 3 from both sides here. So I end up with x minus 3 on the left equals negative 1, all divided by 2y minus 4. Now my y is in the denominator. I can just use the process of clearing the denominator to help bring that up, or I can actually just kind of do the reciprocal of each would work as well. But I'm going to clear the denominator, be a little bit more formal about that. So then I end up with 2y minus 4 times quantity x minus 3, make sure you keep parentheses there, equals negative 1. And so now I want to divide both sides by x minus 3. And I end up with 2y minus 4 equals negative 1 over x minus 3. I'm going to add 4 to both sides, so I have 2y equals negative 1 over x minus 3 plus 4. And then I want to divide both sides by 2. can write it like this. Make sure that fraction bar goes all the way under both. We can put that 4 over 1 if we like. And then I just think of it as being like a 2 over 1, and I'm going to multiply by the reciprocal, and then I kind of have to carry that through, right? So I think using parentheses here is really important. So that might be what, if you didn't end up right in the very tail end of it, is what I was hearing questions on. That may be why. So this will give me y by itself. But then here I have a half, right? Because when I divide by 2, I'm multiplying by the reciprocal. So I'm going to write it as a half, and then have my parentheses there, negative 1 over x minus 3 plus 4 over 1, and then I have to distribute that. Right, equals negative 1 over 2 times x minus 3 plus 2, and I can go even one step further. Negative 1 over 2x minus 6. I wouldn't mark you off though if you didn't have that, as long as it's simplified. It's not a complex rational like it was before. Like up here we have a complex rational. Down here, even at this point, we're fine. And then that would be my inverse. So I'm gonna then rewrite that as f inverse of x, just to be clear it wasn't the original f of x. So that was number 10. So a lot of steps on these. If you didn't get them all on your homework, that's okay. Just want to make sure that you have plenty of practice for this, because I find it's just something that you want to have it be second nature. And then I also need to think about, for number 10, the domain and range. So for f of x, I cannot have this denominator equal to 0. So I want to figure out when that would equal 0 and avoid it. So I would have x not equal to 2, so anything but 2 for domain. So that would be all real numbers such that x not equal to 2 for domain. And then the range on that, I can think about what would the possible y values be given that. I think the easiest thing to do is actually put that in a graphing calculator or Desmos and graph it, or you could plot a few points, but you can really think about it this way. This will, can approach 0, but it can never be 0. So really, we're never going to have a 3. We can have anything but 3, because we can have any other number for x but 2. But if I put a 2 in here, this will come ever so close to 0, but never be it. So we're never going to have a y equal to 0. So that would be all real numbers, such that y is not equal to 3. Okay. The inverse we just did over here. This is my inverse. And if I were to compose my function with my inverse, there's my part 2, okay, part 1. Then I should get x, right, and vice versa. So I'll do one of those just so you can see how that's done. So I'm going to push this up here to give some space. So basically what I'm doing is I'm going to find, whoops, I skipped 3. 3 would be domain and range of my inverse. F inverse domain would be all real numbers such that x is not equal to 3. So I can just catch that right here. I'm totally good. You can also figure out if you were stumped here on what the range of the original f was. You can know it from here because I can't have a 0 there. So 3 would make this denominator in the inverse be 0. So you can kind of look at it that way too. Sometimes that's a nice little, trick. And then the range would be y not equal to 2, which is the domain from up here. So I can't stress that enough to make sure you're tracking with that. I'll do this in a different color. So this is going to be 4. And then I'm going to compose. So f of x is up here. So I have to put this whole thing inside my f function. So I have -1 over 2 times x is now my inverse, right? -1 over 2x minus 6. Whoops, I need to add my +2. And then I have a +3 onto that. So it looks kind of messy to deal with, but once you start simplifying it, it works out okay, because a lot of things are gonna generally just reduce down for you. And I also have to have my -4 here too. Oops. Okay, so I have my 2x, right? That's in place of x. And then I have my -4 and then my +3. Okay, so it's a big problem. It's really big. I gotta cover up my zoom button. All right, so we are going to, okay, so the way we deal with this is we're going to distribute this 2 here. So we're going to have -1 over -2 over 2x minus 6, and then plus 4. 2 times 2 is 4, and then -4, and then our +3. Okay, so this is nice because this will go to 0. So then I just carry on down here, -1 over -2 over 2x minus 6. Then I can actually multiply by the reciprocal, right? So then that's going to be multiplying by a negative, and that'll be 2x minus 6 over 2, and then bring down my +3. Okay, so now this becomes a positive here, so I have 2x, I'm going to distribute this negative, plus 6, and that's all over 2. So I'm going to kind of split that apart just so you can see. 2x plus 6 over 2, and then +3. So I normally you would just do that in your head. This is going to become just plain x, right? This 6 over 2, you can just calculate it out in your head, right? But that should be a negative there, actually, because that's negative. So that works out to have these 3's go to 0, and then I'm just left with x. Okay, so that's the identity, which I should get when I compose my inverses, and that's a lot of sticky, kind of messy math on that one. So it's great if you got even pretty far with that, just in maybe get it fully simplified. And then the domain for that, the inner function was my inverse, so my domain is where I can't have x equal 3, remember. Okay, so that has to be kind of attached all the time because you won't necessarily see it. The domain of the composition is X, right? That could be all real numbers, but this takes precedent over that. So remember, we need the intersection of the inner function, which in this particular way, I went about it for part 4, Roman numeral 4, then you're going to be looking at the inverse as the inner function. And then for 5, you do it vice versa. So it's a similar type problem, but your domain on that is different. It would actually be x not equal to 2. All right, so I hope you found that helpful. And for these, sketching them, it's good if you can sketch it by hand, but these ones I think I just put, use technology and do them out. If you're struggling with that at all, just let me know, but I would just pop it in Desmos. I can actually do that. I'll pause the video and set that up. Right, so I just went in Desmos. I started typing in the function. Just make sure you're using parentheses and stuff. So when I end here with the over 2x plus 4, I have to arrow over to get out from the denominator. So I wanted to show you how I did that. And then plus 3, otherwise it won't come out right. And here is your graph. I'm going to shrink it down a little bit here, but you can see where we're going to approach this to, I don't know if you can see my cursor, but you're never really going to actually hit x equals 2. Okay, so the y also, it'll get close to it, but it never quite gets there. And we could also put the inverse on there, which is our -1, and then divide, and then parentheses 2x minus 6. Now, if you are using Desmos, keep in mind you have to use the x and y that they have here. If you use some other kind of letter, like say the problem had a z or whatever, and you try to type in z, you have to define that and everything first. You can't just do that. So I would just stick to, even if the paper says z, you would type in x or y. And then we have plus 2. Okay, and you can see how the inverse is there and how it really reflects. Okay. So that is it for this lesson. Oh, you can also see how the approaching 3, x equals 3 for the domain on the inverse, and you're approaching, here it would show you, approaching y equals 2 for the range. So you can see how those kind of fit together. And I think there was one more question on number 4, so I kind of want to briefly on part 2, so I want to look at that real quick. I think it's just a matter of tracking for these type of problems and knowing what things equal. So if I have, suppose a of x gives a number of pounds of grapes harvested in California in thousands as a function of the number of years since 1900. So a, I kind of just keep track over here, like a is pounds grapes. Okay, and then x is number of years. So we just kind of think of like, what are those units? And then b of x gives the number of gallons of wine. So b is gallons of wine, and that relates here as a function of the total grape crop in thousands of pounds. So now the a that was here is now the x is pounds grapes. Okay, So you can kind of roll them together, interpret what B of 75 represents with regard to this application. So if I'm looking at the B function, then I would say B is always going to be gallons of wine. So gallons of wine from 75,000 pounds of grapes. Okay, so in that case, that's the X value. But now the inverse, they're going to switch, right? So B inverse related to this is going to be the pounds grapes, and X will be the number of gallons of wine. Okay, so this is saying how many, that's going to give the size of the grapes, all right, sorry, size of the harvest, I could say, in thousands of pounds. That we need to produce the 75 gallons of wine. Okay, and then down here, when we roll them together, this X kind of is related to A, remember, is the number of years up here. So this is going to be in 1975, right? Number of years past 1900. It's going to lead us all the way to the number of gallons of wine. Okay, so it would be number of gallons of wine produced in 1975. So by tracking over here, I'm kind of keeping track of my little things of what equals what, and then I can answer the questions. Your key has it written out much nicer, but that's just the idea of it. I think, just to track as you go. All right, so I hope that was helpful. Let me know if you have any other questions, and have a great day.